see. Let us see what happens in negative half cycle. It is still pending, no? Okay.
Yes, ma'am.
So now when I take negative half cycle as input, okay. So if I take negative half cycle, what is the input that the diode is receiving? Now diode is receiving this as the input.
Negative voltage.
Okay. So it is starting from 0. Any value below 0 is a negative voltage, right? So 0 slowly increasing, going to the maximum value, isn't it? It is going to the maximum value. What is the maximum value?
VM minus VM.
Minus Vm. So that means whatever the voltage you are taking in the negative half cycle, it's a negative voltage, right? That means what about the voltage that this diode is receiving now? Minus
Negative
here,
voltage.
plus here, isn't it? Minus here, plus here. So this voltage polarities are very, very important. Based on these polarities only, we will be deciding what is the state of the diode. Polarities are decided based on what voltage you are giving. So when I'm giving positive voltage, it is plus minus. If I'm giving a negative voltage, as you see with blue color, it is minus plus. Now it is this negative voltage the diode anode is receiving. So when diode anode is receiving a negative voltage, what is the state of the diode now?
Reverse.
The diode doesn't conduct. That means, as you said, diode non-conducts. So non-conduct because the diode is in now reverse biased condition. So when diode is in reverse biased condition, what is its state shown as?
Open circuit.
Off state, right? It is off state. When the diode is in off state, we replace it with
Open circuit.
open circuit. So what is now to the circuit you see here? So no more the diode exists. So instead your circuit becomes like this. So this is RL. Again it is the same. Across RL we measure V0 and here you are applying now the input Vin. But your input is negative voltage. So I have shown negative first, positive next. Clear? But for this state of the diode, what is I? That is important. Earlier we said that I is flowing in the circuit. Now in this case, what is I?
0.
Right. Why I is 0?
It is an open circuit, ma'am.
Yes. I is 0 because there is an open circuit here. And current doesn't flow in series when there is an open circuit. When I is 0, what is V0?
0.
Why? This basic relation doesn't change. V0 is equal to I into RL. But what is changing? I is changing. Since I is 0, you find that V0 is 0. That means if you see here, my input is having negative half cycle. Okay. But what is for this negative half cycle current I?
0.
0. When current I is 0, what is output voltage V0?
0.
0. So here I can see, what is that we see here? You can see the input having both the half cycles. Isn't it? Input is having both half cycles. But what is your output is having now? It has only one half
Positive.
cycle. What happened to the other half cycle?
Cut, clipped.
Yes, it is clipped or removed. Okay, it is removed. Now, if you see that this is continuous, for example, if this waveform is continuous in nature, what is the next output going to be here?
Positive half cycle.
Yes, next output is going to be positive half cycle, then
0.
0, then positive, then 0. The same will be extended to the output voltage V0. So what is that? Wherever I is there, you find that the current flows, right? You see that current flows. So that means again here I have find positive half cycle, 0, positive half cycle, and this continues. So my input is having both the half cycles, whereas output has only
Positive half cycle.
one positive half cycles, isn't it? And what is being clipped here?
Negative half cycle.
Negative half cycle. So if I have to name this series clipper in terms of positive or negative, what do you think is this type of clipper is? We said series clipper is positive and negative, right?
Positive.
This is which type of clipper now? If I want to write its name.
Positive series.
Positive.
Negative, ma'am. It clipped negative side.
Yes, since it clipped negative waveform, we call it as a negative series clipper. Very good. We call it as a negative series clipper. So this is how we explain the operation of a negative series clipper with respect to this circuit. Okay. Finally, this waveform which I have shown is for your understanding. But in the examination or in your notes or examination, it is sufficient if you write or if you draw just the input waveform and the output waveform. This waveform showing of I is not required. So that means simply you will draw a waveform like this. So with input cycle, show that this is input voltage V in. So that's why in clippers, we show only the input and output waveforms. This is omega t angular axis. Okay. And on the same axis, we show output voltage also. So here, you show here, this is V0. Okay. But what is clipped here? Negative half cycle. So to have a clear waveform, what you do is you extend these points onto x-axis like this, so that you can have a clear positive and negative half cycle periods. Okay. So after extending this, what you do is, since it is clipping negative half cycle, so we show positive waveform like this. This will be 0. And again, what we will show, this is positive half cycle and this will be 0. So that it lies in the same periods for uniformity. Okay. So this is what you have as a negative series clipper. Clear this one?
Yes, ma'am.
Now, if you want to get positive series clipper, what do you think is the change?
Position of voltage source.
Position
Orientation.
of orientation
Orientation.
of diode. So what do I mean by orientation of diode?
Changing the position of diode. Reversing.
Reversing. That means for me to give negative clipper, I connected anode first, right? But to get a negative series clipping, interchange the terminals of the diode. That means connect cathode first, anode next. So it gives you positive series clipper. Okay. So what you do is, for tomorrow's class, try to take the circuit like this. So what is the circuit you can take here?